Now we're going to do preview activity 2 from section 3.4. And here we're going to do a proof by cases. So the proposition we're given in this preview activity is if n is an even integer, then n squared plus n is an even integer. And so then they started the proof for us for this one. So we let n be an even integer. Then there's just an integer m such that n equals 2m. Substituting, and then I missed this part, this in the expression n squared plus n yields, oh, I've got the wrong marker. N squared plus n equals 2m squared plus 2m equals 4m squared plus 2m equals, and then here we're trying to remember what we're trying to prove. We're trying to prove that this number is even. So we want to factor out a 2. 2 times 2m squared plus m. Thus, by definition of even, n squared plus n is even. Okay, now we're being asked to do it for when n is odd, and then we're going to put it all together. So, proposition 2. Fit that guy right there. All right. Proposition 2 is that if n is odd integer, then n squared plus n is even. Okay. Well, we'll start off with the usual. Well, the proof. So for our proof, we'll let n be an odd integer. Okay, well, what's next? Well, what does it mean to be an odd integer? Then there exists an integer. Should we use m again or a different letter? Let's use m again. An integer m such that n equals 2m plus 1. Okay. Now I need to, what's the next step? Well, what am I trying to show? I'm trying to show that n squared plus n is even. So substituting this into the expression n squared plus n gives us n squared plus n equals 2m plus 1 squared plus 2m plus 1. Now, squaring that, we would kind of FOIL, so it'd be 4m squared, and then you're going to have two linear terms that add up to, I'm just going to do the algebra real quick here, so it's just, we'd have 2m times 1 plus another 2m times 1, which is 4m, then plus 1 plus 2m plus 1. Simplifying, you get 4m squared, and how many m's we got? 6m. You got plus 2, factor the 2 out, and you have 2m squared plus 3m plus 1. Thus, n squared plus n is even by definition. All right. Oh, you can't see that, I'm sorry. So we factor out the 2, and thus n squared plus n is even by definition. Okay, now the easiest one is proposition 3. Okay, so proposition 3, maybe I'll just switch to a piece of paper here. Okay, proposition 3 says that if n is an integer, then n squared plus n is even. Proof. Okay, now I've already proved this for even integers. I've already proved this for odd integers. So I'll say let n be an integer. Okay, now if it's integer, it is either even or odd. Then n is either even or odd, right? Then if it's even, then proposition 1 tells us n squared plus n is even. If n is even, then proposition 1 tells us that n squared plus n is even. If n is odd, then proposition 2 tells us that n squared plus n is even. Okay? Thus, the conclusion follows from both cases. That's one way to say it. Let's see, we're trying to think of other ways to say it. Thus, the conclusion follows from both cases, right? Yeah. Thus, the conclusion follows from both cases. Okay, it kind of summarizes the fact that we broke it into cases, and it's either even or odd. If it's even, we proved that. If it's odd, we proved that. And so then we're done. We need the last sentence that kind of says, so we're done now. Okay? That completes progress. Preview activity 2.